PS 29.1, Earth in Space. The main idea of this section is Earth revolves in elliptical orbit around the Sun. Ancient observations: a sphere is a round, three-dimensional object, the surface of which is the same distance from the center in all directions. First, no matter where you are on Earth, objects fall straight down to the surface, as if they were falling toward the center of a sphere. Second, Earth's shadow on the moon during a lunar eclipse is always curved. And finally, people in different parts of the world see different stars above their horizons. If Earth were flat, everyone would see the same stars. Everyday evidence of Earth's shape. Gravity is the attractive force between two objects that depend on the masses of each object and the distance between them. Earth has a magnetic field that protects us from harmful radiation from the sun. This field resembles the field surrounding a bar magnet. Here is your bar magnet, south and north poles. Earth's magnetic field is running from Earth's north magnetic pole to its south magnetic pole. This axis is tilted 11.7 degrees from Earth's geographic axis of rotation. The locations of Earth's magnetic poles change slowly over time. Large-scale movements called magnetic reversals occur, on average, every 200,000 years.
On Arctic nights, the aurora often flames across the winter sky. What is it, and where does it come from? This is where the tale of the aurora starts. On the Sun, a star of average size among billions of other stars in our Milky Way. The Sun acts as an enormous power plant. The energy is created deep inside the core of the Sun. Here the temperature is over 14 million degrees, and the pressure so enormous that hydrogen atoms are squeezed together into another element, helium. This nuclear reaction releases energy. The light radiates outward from the core of the Sun. In the outer layers, the heat moves to the surface in huge eddies called convection cells. These electrical currents of charged gas create magnetic fields inside the Sun. In some places, strong magnetic fields push their way up through the surface. They slow down the eddies of hot gas. The surface cools, and darker sunspots appear. The electrically charged gas is called plasma. The plasma drags the magnetic field further outwards. The magnetic field stretches and twists like a rubber band, and then the rubber band breaks. Several billion tons of plasma is hurled out from the Sun. This is called a solar storm. The solar storm can reach speeds over 8 million kilometers an hour. After 6 hours, it blows past the planet Mercury. After 12 hours, the planet Venus. Solar storm reaches Earth. When the solar storm reaches our planet, something strange happens. An invisible shield, the Earth's magnetic field, deflects the storm. The magnetic fields couple together and create a funnel where the gas streams down on the daylight side of the pole. This is the daylight aurora. The magnetic fields stretch further back and couple together. The magnetic rubber band breaks, and gas from the solar storm streams along the magnetic lines towards the poles on the night side. This is the nighttime aurora.
An area within Earth's magnetic field called the magnetosphere deflects harmful radiation from the sun. The sun produces streams of electrically charged particles that travel toward Earth. These charged particles spiral along Earth's magnetic field lines toward Earth's magnetic poles. Electrically charged particles collide with atoms in the atmosphere and emit light. This light is called the aurora borealis in the northern hemisphere and the aurora australis in the southern hemisphere. Earth's orbit is shaped like an ellipse. An ellipse is an elongated, closed curve with two foci. Earth is closest to the sun, about 147 million kilometers away in early January, and is farthest from the sun about 152 million kilometers away in early July. Earth is the only planet whose characteristics make it possible for life as we know it to survive. Earth's oxygen-rich atmosphere is one reason it is able to support abundant life.